Ever wondered how that clear, shiny window pane or sparkling drinking glass actually comes to life? It all starts with sand, but turning ordinary grains into a smooth, strong sheet or container requires a fascinating blend of science, engineering, and a little high-temperature magic. Let's go inside a glass factory and follow the full journey from raw sand to finished glass product. Gathering raw materials. The ingredients of glass might seem simple, but it's actually a mixture of carefully selected raw materials. The primary ingredient is silica sand, which is rich in silicon dioxide, SiO2. Not all sand will do. High purity, fine-grained sand is needed to produce clear, strong glass. Other key ingredients include soda ash, sodium carbonate, lowers the melting temperature of silica, making it easier to work with. Limestone, calcium carbonate, improves the chemical durability and strength of the glass. Alumina, magnesium oxide, or other trace minerals, sometimes added to improve durability, color, or thermal stability. The exact recipe depends on the type of glass being produced. For example, soda lime glass is common for windows and bottles, while borosilicate glass, used for labware, contains boron to resist thermal shock. These raw materials are delivered to the factory in bulk, usually in large silos or containers. Quality control at this stage is essential, as impurities can cause bubbles, cracks, or discoloration in the finished glass. Batch mixing, preparing the glass formula. Once the raw materials arrive, they are weighed and carefully blended to create what is called a batch. The batch is essentially a dry mixture of sand, soda, limestone, and any other additives. The ingredients are mixed thoroughly to ensure uniformity. Inconsistent mixing can lead to weak spots or imperfections in the final glass. Automated systems now handle most batching in modern factories, though historically this was done manually. Melting, turning sand into molten glass. The batch is then fed into a massive glass furnace. This is where the magic really begins. The furnace can reach temperatures of 1500 degree Keys, 2732 degrees, or more. At these extreme temperatures, the raw materials melt and react chemically to form molten glass. During melting, silica reacts with soda ash and limestone to create a smooth, viscous liquid. This liquid is constantly stirred or carefully circulated to ensure uniformity. Any undissolved particles or bubbles are removed during this stage, because even tiny imperfections can affect clarity and strength. The melting stage can take several hours, and controlling the temperature is critical. Too hot, and the glass can become unstable. Too cool, and it won't flow properly. Refining, removing bubbles and impurities. Even after melting, the glass may contain bubbles or other impurities. To remove these, the molten glass undergoes a refining process. During refining, the molten material is kept at high temperature to allow bubbles to rise to the surface and escape. Some factories use fining agents, special chemicals added to encourage bubbles to merge and rise more quickly. The goal is to achieve a clear, homogeneous molten glass, ready for shaping. Forming, shaping the glass. Once refined, the molten glass can be shaped into its final form. There are several forming methods, depending on whether the factory produces sheets, bottles, jars, or specialty glass. Common forming techniques include float glass process, for flat glass. Molten glass is poured onto a bath of molten tin. Because glass naturally floats on tin, it spreads out evenly, forming a flat surface. Rollers gently guide the glass across the bath while it cools slowly, producing perfectly smooth and flat sheets for windows and mirrors. Blow and blow, press and blow, for bottles and containers. A gob, a measured portion of molten glass, is dropped into a mold. Air is blown into the gob to shape it into a hollow bottle or jar. Press molds may be used for jars or thicker glass containers. Drawing or rolling for specialty shapes. Molten glass can be drawn into sheets or rolled into tubes, rods, or other industrial shapes. During forming, controlling temperature is crucial. Glass must be hot enough to flow, but not so hot that it deforms uncontrollably. Modern factories use precise computer-controlled systems to maintain optimal conditions. Annealing, cooling slowly to reduce stress. After forming, glass is still extremely hot and fragile. Rapid cooling could cause cracks or internal stresses. To prevent this, glass moves through an annealing layer, which is a long, temperature-controlled tunnel. In the annealing process, the glass cools slowly over several hours. This gradual cooling allows internal stresses to relax, ensuring the final product is strong and stable. Improper annealing can lead to weak glass, prone to cracking, even under minor impacts. Cutting and finishing. Perfecting the product. Once cooled and stable, the glass is ready for finishing touches. Cutting and sizing. Flat glass sheets are cut to the desired dimensions using diamond-tipped tools or automated cutters. Polishing and edge finishing. Edges may be polished to remove sharpness and improve safety. Tempering, optional. Some glass is reheated and cooled rapidly to create tempered glass, which is stronger and shatters into small, safer pieces if broken. Coating or laminating, optional. Glass can receive coatings for UV protection, reflection, or added strength. Laminated glass is made by bonding multiple layers with plastic for safety or insulation. For bottles and jars, finishing includes inspection for defects, surface smoothing, and sometimes labeling or coloring. Color can be added during melting, using metal oxides, or applied afterward. Quality control. Ensuring perfection. Quality control happens at multiple stages. Sensors, cameras, and manual inspection ensure glass is free from bubbles, cracks, or uneven thickness. For windows or mirrors, optical clarity is tested. For containers, dimensions, strength, and durability are checked. Glass factories aim for near perfection because even small defects can compromise strength or usability. Modern factories often have automated inspection systems that detect tiny scratches, bubbles, or warping. Packaging and shipping, ready for the market. Once inspected, the glass is carefully packaged to prevent breakage. Flat glass sheets are stacked with protective layers, while bottles are placed in cartons or crates. Some fragile specialty glass may require foam or other cushioning. Finally, the packaged glass is shipped to distributors, construction sites, or manufacturers. The journey from raw sand to finished glass can take several hours to days, depending on the type of product and production line. Sustainability in glass production glass is infinitely recyclable, which is one of its greatest advantages. Scrap glass from production or post-consumer recycling can be melted and reused, reducing the need for raw materials and energy. Many factories incorporate recycled glass, cullet, into their batches, which lowers melting temperatures and reduces CO2 emissions. Modern glass factories are also investing in energy efficiency, using waste heat recovery and alternative fuels to minimize environmental impact. Conclusion: from sand to shiny masterpieces. The journey from simple sand grains to sparkling glass is a fascinating mix of chemistry, physics, and precision engineering. Every window, bottle, jar, or mirror you see is the result of careful selection and blending of raw materials, high-temperature melting and refining, precise forming techniques, slow annealing for strength, finishing, inspection, and packaging. It's amazing to think that something as ordinary as sand can be transformed into a product so versatile, beautiful, and essential to daily life. So next time you drink from a glass or admire a window, remember the incredible journey it took, full of science, heat, and skill, to become part of your everyday world. If you enjoyed this inside look at how glass is made, don't forget to like, subscribe, and leave a comment telling us what industrial process you'd like to explore next.